That's not the page. All right. I keep clicking on the wrong page on my computer. Okay. So, gravitational potential energy. Anybody remember the equation for gravitational potential energy?
Y equals mc squared.
No. That would be E equals mc squared. Yeah, not just
I
Y.
tried.
Yeah. You were just substituting variables. That's
I told
fine.
you that calculus crap was good thing. Never not good.
All right. So, gravitational potential energy. This is the energy you have from how high up off the ground you are. Okay? So gravitational potential energy is generally abbreviated GPE, all capital letters, and it's actually nice and simple to calculate. This is why it's going to be really helpful when we put it into like the equations with work and kinetic energy, because it is by far the simplest. It's going to be your mass, so how much matter you're lifting up, shockingly, times the acceleration of gravity, since this is gravitational potential energy. So we have mg times the height it is off the ground. And that's all it is.
Why is it off the ground?
Because we defined gravitational potential energy as the energy you have from lifting something up against the force of gravity.
What if it's on a hill?
So that's one of the things with gravitational potential energy. You actually have to define where your 0 point is. So if we look at, a lot of times, if we look at like a building, if we have a room here, and there's a table, and what should we have on the table?
A unicycle.
A unicycle? All right, so we have a unicycle on the table. Okay? If this table is a meter tall, it's not that tall. My desk is only about a meter tall. So it's not that tall.
How tall is the unicycle then? Because it's like.
Maybe the unicycle is a meter tall. It's one of the big ones. All right. So we've got 1 meter. How much does our unicycle? How much mass does it have?
Wait, let me look this up.
Wait,
60 million.
Yeah.
micro.
I'm looking up how much it weighs. 10 to the power of 22 kilograms.
10 to the power of 22 kilograms.
Yeah.
It's a really heavy.
That's the weight of the moon. So that's how
Okay.
much is inside.
So our unicycle has the same mass as the moon.
Yes.
So it's 22nd.
Yes. Kilograms.
All right. So to calculate its gravitational potential energy from the floor, so we're pulling this 0 here, we would get our 10 to the 22nd kilograms times 9.81 times, that's meters per second squared, times 1 meter. Okay? So what would we get?
9.81 times 10 to the 22nd.
23rd, actually.
Oh.
I'm pretty sure. Because it should be,
Wait, no.
no, it would,
Yeah, it is the 20.
is it, somebody do it on your calculator and check.
Check it
Because
out.
9.81 is in scientific.
Thanks, no. Yeah, it's just
Yeah.
1 times 10
Okay.
to 22.
So then it would just be, okay, you're right.
Aha.
9.81 times 10 to the 23rd.
It would be?
Yeah.
Okay.
I
That's what I
got
thought.
20 seconds.
Yeah.
Because this is technically not scientific notation. Because it's 10 to the 22nd, so it should be 1 times 10 to the 23rd, which is different than 10 to the 22nd.
1 times 10 to the 22nd or 1 times 10 to the 23rd? Or is it just 10 to the 22nd?
Well, technically, I have to
I got 20 seconds.
You got 22nd?
Yeah.
10 to the 22nd.
Okay. Let's see what this does.
10 to the 22nd.
Yeah, I got.
I'll show you.
It is 22.
So is it 10 to the 22nd or times 10 to the 22nd? Because that's where.
You're there.
We'll just do 10 to the 22nd.
Yeah, 10 to 22.
We want to get this right.
Also, I forgot to mention that there's a number of hundred.
What's the rest?
Okay, so this has conclusively said that it is the 22nd. Okay. So we are going with the 22nd. Okay. All right. What units would it have? Nope.
Kilogram, kilogram.
Gravitational potential energy.
Joules.
Joules. Okay. Joules is the unit for energy, and work, because work is a form of energy. Okay? Or a measure of energy. Everybody good?
Yes.
So that's how we calculate the gravitational potential energy. Now, let's say that this is a really tall building. And we've decided that instead of the floor being our zero of potential energy, down here on the ground is going to be our zero of potential energy. Okay?
What's the height of the break?
What height are we using?
The tallest building in the world.
Make sure you get it in kilometers.
Kilometers. Are we going from the top of the building or to the tip of the building?
Top.
Top.
That's like 0.28. That's how that works? Because it's like 820.
What you said meters?
It's 820.
Yeah, 800.
We want meters, so we don't want kilometers.
So it's 828.
All right, so we've got 828 meters. We still have our unicycle up on our table. So the total distance above the ground is going to be 829 meters. So we come over here, we make this 829. What do we get now? It is very large. It should at least be like 10 to the 25th. 8 something times 10 to the 25th.
Yeah. Good work. Good work.
All right, so just keep in mind that your 0 point is going to change your potential energy.
Got it.
Have a good day, guys.
0 point changes the potential energy, no?
You know, I'm saying it.
Yup. See your screen.
Have a good day.
Stop.
No.